In this video I'm going to give you some background information or some extra explanation about how the unit circle works. So you can see over here I've already drawn my unit circle up. Okay, so a unit circle means that it has a radius of 1. So that's where I've got these 4 coordinates in purple around the outside. If it has a radius of 1, that means I've got across 1, up 0, so 1, 0. This would be 0, 1, negative 1, 0, and 0, negative 1. I've also marked around the outside the angles in both degrees and in radians, so those reference angles that we look at all the time. Inside the unit circle, I've just drawn a right angle triangle. Now I could have drawn my right angle triangle anywhere around the unit circle. I've just picked the first quadrant because it's easy. And I don't know its length here, and I don't know its length there. So I've labelled that side X because it's the horizontal, and that side Y because it's the vertical. Okay, X and Y, that's usually the way we label things. I do, however, know its hypotenuse has a length of 1 because it is a radius of the circle, so it must be a length of 1. And I've put a little angle in there. So from this triangle, we can come up with a rule or a definition for sine, cos, and tan. For instance, we know sine theta equals O over H. So according to this triangle, if this is our angle, the opposite side is Y and the hypotenuse is 1. So sine theta equals, now instead of writing Y over 1, there's no reason why we need to write divided by 1. So we can just say that sine theta equals Y. Okay, that's an important rule. We're going to come back to that one. But let's keep going and see if we can find cos and tan. So cos is adjacent over hypotenuse. So if this is our angle here, adjacent to it is X, and the hypotenuse is again 1. So if we write cos theta equals just X, because there's no need to divide by 1. And our last rule, tan is opposite over adjacent. Okay, so if this is our angle here, the opposite is Y and the adjacent is X. Alright, so those 3 rules there are actually pretty important, and they let us calculate some pretty cool things. So I'm going to circle those. So we're going to refer back to those. That one. That one. And that one. So what they tell us is, okay, at any position around our unit circle, which we can create by making the angle anything we like. Okay, if the angle was 110, well, we'd be somewhere over here. Okay, if the angle was 300 degrees, we'd be somewhere down in this quadrant here. So no matter what the angle is, if we can find our angle theta, okay, and we know what its coordinate is on the unit circle, well then the y value of that coordinate will be sine of that angle, the x value of the coordinate will be cos of the angle, and the y divided by the x will be the tan value of that angle. Now, for any other normal angle, it's not really much use, but it does let us calculate some important exact values that aren't in the exact angle triangles. Because we know the coordinates at 1, 2, 3, 4 points. So, without using a calculator, we can now do things like calculate sine of 3 pi over 2, for instance. Okay? 3 pi over 2, if I'm reading around the outside of my circle, is down here at this coordinate here. And the sine of the angle is always the y coordinate. So x is 0, y is negative 1. Check it on your calculator. Okay? We could do things like cos of 180. Okay, without using our calculator. So around our unit circle, 180 is over here, which is this coordinate here, negative 1, 0. And cos is always the x value. So cos of 180 is negative 1 because that is the x value at that point. Let's try a tan. Let's try tan of